I'm taking my coffee here on the terrace at Chandler Hall, and it's a gorgeous day today, isn't it? I really like coffee. You know, if the price of coffee went up a little bit, I think I'd just buy it anyway. In fact, if the price of coffee went up a lot, I think I'd just buy it anyway. I think I just really like coffee. You guys really like coffee? There are some goods we don't really care how much it costs. This is one of those for me. Price goes up, I'd still buy it. The idea I'm getting at here is called elasticity. In this course, we will focus on two different understandings of elasticity, but there's a bunch of different elasticities that economists study. We're going to zoom in on price elasticity of demand and price elasticity of supply. So first, very quickly, looking at price elasticity of demand, what is it? It's a measure of responsiveness. Elasticity, okay, you think elasticity like elastic, like stretchy? That's exactly what we're talking about. How much does demand, does the amount buyers want to buy, stretch in response to price changes? How stretchy is our demand? Does quantity demanded change dramatically in response to price changes? Or do consumers pretty much buy about the same amount regardless of what happens to price? This is the question of price elasticity of demand. So as you think about it, do changes in price impact whether or not I buy this thing? Well, yeah, I guess for some goods, if the price goes up, I'll stop buying it. And for other goods, if the price goes up, I don't really care. I just keep buying it. So let's start teasing out why that is. First off, one thing that can influence whether or not price changes dramatically change how much we want to buy. Is it a want or a need? Is it a luxury product? In general, if it's a luxury product, well, you tell me, you think about it. If it's just some silly flippant thing that you just kind of want, if the price goes up, are you going to be more price sensitive or less? Are you going to respond? Are you going to buy it if the price goes up? Oh, probably not. If it's just some silly luxury product, you're not just going to say, I'll just buy it anyway. It's fine, right? Okay. So is it a want or a need? If it's a need, you know, if you have to have it, if it's medical care or a medication you have to live, you're just going to buy it. You're not going to care if the price goes up. Okay, if it's a want, you're going to be more price responsive. If it's a need, you're going to be less price responsive. What about the availability of close substitutes? For some products, there are lots of substitutes. If you like to cook, you'll recognize that butter has a bunch of substitutes. Instead of butter, when you're cooking, you can use oil, you can use lard or shortening, you could use margarine if you're into that kind of thing. It's not really my bag, but I respect it. Whatever you're into. I mostly use lard instead of butter if I'm switching, which I understand people think is atrocious these days. Whatever. Hey, okay, there's lots of substitutes for butter. If the price of butter goes up, you say, oh, well, I guess I'll switch and buy lard, or I'll buy some other butter alternative. What about eggs? Are there substitutes for eggs? I mean, I guess there's some other cheap protein that you can put in your food, kind of like eggs, maybe like tofu or like a soy-based protein. I guess. There's really not a lot of good substitutes for eggs. They're kind of a unique thing. So this is part of the reason why when we see the price of eggs kind of spike a little bit, well, people just keep buying them. So if there's a big supply shock on eggs, like there were several different times over the last 5 years or so, the price tends to shoot up because people just keep buying them. They're not very price responsive with eggs because there's not a lot of close substitutes. Another question we might ask is, what share of your budget is it? Okay, so you're thinking about buying a car, you look at it on the website, it says 20 grand. You get down to the lot and the price is 10% higher at the end of all the paperwork than it was on the website. Okay, 10%, that's from 20 grand to 22. We'll just use that as nice round numbers here. It's 22,000. Okay, well, that's a 10% price increase. Are you still going to buy it? Well, maybe not. $2,000 is a lot of money, Compare that against maybe your gonna buy a t-shirt on Amazon, but you don't feel like putting in the order right now. So you say, I'll add it to my wish list. It's $10 and I'll come back and buy it later. And then you check back, you're about to put in an order at the end of the week and you're like, oh, okay, I'll buy that t-shirt now. And you see it's not $10, it's 11. Well, it's the same 10% price increase. Is that $1 going to change your mind? Well, not really. Well, why? Because the share of your budget that dollar is way less than those $2,000 for the car. So how much of your budget is part of the question too? Time horizon. How much time do we have to make the decision? We're talking about buying a used car or buying a car at all. I have bought cars when I needed a car, and I have bought cars when I did not need a car. And my 2 cents is you want to buy a car when you don't need a car. Because when you do not need a car, you get to search around and find a different substitute. You have all the power. If you have to have a car that day or in the next couple days, you're going to be forced by circumstance, more or less, to go buy some car, and you're going to be way less price responsive. Much more likely you get a bad deal. That's happened to me. If you really got to have that car, if you have very little time to make the decision, then you're going to be less price responsive. If you have more time, you can search more, look at more substitutes, and you can be more price responsive. And finally, there's this idea of like the way we define the market might matter. This one's always a little ethereal or like heady, maybe a little theoretical to me, but okay. Just for an example, if we define the market we're talking about as food, well, is food a want or a need? Yeah, it's a need. Are there substitutes for food? Well, no, you're not going to eat rocks. I mean, we may have defined the market so broadly as to make it inelastic, where if we say, we're not just talking about food as this very broad category, we're talking about vanilla ice cream. Okay, well, that's a very different kind of question. So the way we're kind of zooming in on the definition of the market matters. Okay, so all of these things can influence price elasticity of demand. So how are we going to calculate price elasticity of demand? And we are going to calculate it. We're going to use this very simple formula. Price elasticity of demand is equal to percent change in quantity demanded over percent change in price. Price elasticity of demand is equal to percent change in quantity demanded over percent change in price. Now, this is the easiest formula that I can show you on price elasticity of demand. Traditionally, a lot of economics textbooks and courses will have you use what's called the midpoint formula of price elasticity. I'm not going to have us do that just because I don't know that it helps us. It's a much harder formula, and I think it distracts from the point. The thing I love about this very simple formula, which essentially is just the mathematical definition of what price elasticity of demand is, what I like about it is that it keeps it very straightforward and you understand directly what it is that we're talking about. How is this formula going to do all that? Well, what are we asking? We are asking how much does the amount buyers want to buy respond or change in response to a price change? So what do? We just make a fraction. And on the top, we put the response, and on the bottom, we put the thing that drove it. So we get this percent change in quantity demanded in response to the percent change in price on bottom. So then, whichever is bigger is going to determine the elasticity. If the change in price is huge and the change in response, the amount buyers want to buy is small, the change in the amount buyers want to buy is small. Well, if the number on the bottom is big and the number on top is small, that's going to make a little fraction. On the flip side, if there's a little price change and buyers buy way more or way less, number on the bottom is little, number on the top is big, well, that's going to be not a fraction, but a number greater than 1, right? And so we'll work through each of these possible calculations, but it's a very simple formula. And again, it's just rooted in this idea of trying to mathematically measure responsiveness of buyers, okay? So our first example here, perfectly inelastic demand. Perfectly inelastic, not stretchy, not even a little bit stretchy. The price goes up and buyers buy the exact same amount. regardless of what happens to the price. It goes up, down, wherever. Buyers just buy the same amount. This is perfectly inelastic demand. So there is some quantity at which demand is fixed. Buyers just know how much they want. I give the example here of some critical medication that you have to live. Okay, if the price goes up, are you going to buy more? No. If the price goes down, are you really going to buy more? I mean, maybe if you kind of want to like stock up if that's possible, but generally you just buy the amount that you need. If you have to have this medication, you have to have it, and you just buy it regardless of what happens to the price. And we can see that the demand curve for perfectly inelastic demand is straight up and down, because price, our y-axis, can fluctuate like crazy. It doesn't matter. Our x-axis, quantity, is fixed. And when I look at this graph of inelastic demand, perfectly inelastic demand, to me it looks like an I. You like that mnemonic? Inelastic demand, perfectly inelastic, looks like an I. Inelastic? Okay, just me. Oh, my jokes, are they making it through? All right, that's enough. Got another one here. Inelastic demand. So this is relatively inelastic demand. So we see a 22% increase in price leads to an 11% decrease in quantity demanded. So price goes up by 22%, quantity demanded goes down by 11%. Well, what is the calculated elasticity? Let's send it over to the marker board and solve this one real quick. Let's calculate our elasticity. All right, so we've got our formula here. Price elasticity of demand is equal to, all right, fancy notation here, but very simple, percent change in quantity demanded over percent change in price. So for this one, this first example, our percent change in price was 22%, and our percent change in quantity demanded was 11%. Now I want to make a note here. Okay, yes, the amount buyers wanted to buy went down. This went up and this went down. So technically there's a negative here. We're not going to worry about that. We're just going to focus on absolute values for our purposes here, okay? So just think absolute value. So just think about the number. Don't worry about the sign, okay? Percent change over percent change. Notice we have percent over percent. The percents are going to cancel out. And 11 over 22 is 1 over 2 or 0.5, however you want to express it, okay? So percent over percent, the percents cancel out. This is not a percentage. This number we get at the end is 0.5 or 1/2. That is an elasticity. It is not measured in percent, okay? So this elasticity of 0.5, 1/2, it is less than 1, meaning the change was bigger than the response, inelastic. The response is not stretchy. So we should see that this elasticity is 0.5 or 1/2, meaning that since it is less than 1, demand is relatively inelastic. This 1/2 means that the change in price was bigger than the response. Buyers were not very responsive to the price change. I use the example here of cigarettes. Obviously smokers generally are addicted to the cigarettes. The price goes up, they're probably just going to keep buying it. And so perhaps this is a good example of inelastic demand. I do want to point out this possibility, but I won't spend much time on it. If the price change and the response are at a 1-to-1 ratio, meaning a 1% increase in price leads to a 1% decrease in quantity demanded, we call that unit elastic or unitary elastic. It'll become more important if you keep studying economics. That's a relatively important elasticity to like managerial economics or like business economics, because it's going to tell you the point at which raising prices no longer yields additional revenues. But we're way out in the weeds here. Just wanted you to be aware you could calculate it, and your calculated elasticity is equal to 1. That is called unit elastic demand. Okay, what about elastic demand? Well, we can see that our demand curve is starting to get a little flatter in this visual example here. So on this one, a 22% increase in price leads to a 67% decrease in quantity demanded. Price goes up a little bit, quantity demanded goes down by a bunch. Again, let's throw this one out to the marker board real quick to show you how to. All right, so we've got our second example here. Again, price elasticity of demand is equal to percent change in quantity demanded over percent change in price. In this second example, our percent change in price was again 22%, but our percent change in quantity demanded was 67%. Okay, 67% over 22%. 67 over 22. This is going to be, we'll just do a little rounding here. You guys bear with me. This is roughly equal to, that's a really pretty roughly equal to sign, right? Roughly equal to 67 over 22, roughly equal to 3. And I'm going to draw a really ugly 3 too. All right, here we go. 3. Roughly equal to 3. So what can we conclude? Because percent change in quantity demanded is greater than the percent change in price, because the response, the numerator, is bigger than the original price change, the denominator. This is responsive. This is stretchy. This is Okay, so we found an elasticity of about 3. Price went up by 22%. Quantity demanded went down by 67%. So 67 over 22 is roughly 3. That 3 is greater than 1. The response was bigger than the price change, so we say that demand is elastic. I've given an example here of Uber rides. Now, how are Uber rides elastic? Famous paper by the very well-known economist Stephen Levitt, who wrote the book Freakonomics with a co-author. He did a paper on Uber rides in Chicago, and he found that during surge pricing, which is like on like Saturday nights or other times that Uber is very, very busy, the app will jack up prices for 2 reasons. For one, to encourage encourage drivers to drive people around, but also to discourage people from, using the service. So they're trying to bring the buyers and sellers of rides into balance, right? So he found that when those prices shoot up, that buyers generally tend to stop riding, right? So they go do something else. They find some other way to get a ride than taking the Uber. So he finds price responsive or elastic demand, yeah? I will throw this out really quick. If we get a perfectly horizontal demand curve, we call that perfectly elastic demand. I do not have a great example of a product like this, where above some price, you buy none. Below that price, the market buys an infinite amount, or a hypothetically infinite amount, buy as much as, okay, I don't have a good example of that right now. So let's move on. Price elasticity of supply. This is the exact same idea applied to supply, so let's go through it quickly. A measure of responsiveness of quantities supplied, the amount sellers want to sell in response to price changes. Price elasticity of supply, where we had all these different questions for price elasticity of demand, is it a want or a need, so on and so forth. On the seller side, we really just want to ask, can we make more? Can we ramp up production? Is it even possible? Because if it's easy for us to make more stuff and the price goes up, we're going to do it because we're in the business to make money, right? So price goes up, we want to make more available if we can. So can we? That's essentially the question. And the formula here for price elasticity of supply, you guys are going to love this, is literally the exact same formula as for price elasticity of demand. You just take percent change in quantity, now quantity supplied, divided by percent change in price. Again, you're just measuring responsiveness of the amount sellers want to sell in response to a price change. So you put the price change on the bottom in percentage form, you put the quantity supplied response on top in percentage form, and you make a fraction, and that's going to tell you, if it's less than 1 or greater than 1, that's going to tell you the relative elasticity. So let's go through some. Same deal, we'll take the extreme case, perfectly inelastic supply. Sometimes, regardless what happens to the price, sellers are going to sell the same amount. What is an example of this? Hey, we got a luxury apartment in New York City. You guys think even if the price goes up that they're going to be making any more of those? No, it's basically perfectly inelastic. It's really hard to make new apartments in New York City, or really a bunch of the major cities, because land is so constrained in a lot of the major cities, not just in the US, really anywhere, that space downtown is so incredibly valuable and so incredibly scarce that they're not just making new apartments all the time. So very inelastic, and of course, inelastic, regardless what happens on the y-axis price, the x-axis is pretty much fixed. And that's why, same deal for supply, inelastic on our model, it's going to look like an I. All right. Let's see what else we got here. We got a movie theater, relatively inelastic supply. Price goes up, in this case by 22%. Quantity supplied goes up by 10%. So the price goes up, sellers want to sell more, but they really can't dramatically change how much they're going to sell. Now, the movie theater is an imperfect example. Hey, they don't really change their prices. Hey, whatever. Well, can we ramp up production? Let's focus on that question. Can a movie theater really sell way more tickets? If the price goes up, can we sell way more tickets? Well, not really. There's really only so many theaters. And if we take a showing out of, we take a movie out of one theater, then we're taking showings from some other theater. You guys can see that's going to make it, we're going to be constrained in our ability to ramp up production. So this is our example of inelastic supply. Do we need to check the math here? Just quick check. The percent change in price goes on the bottom, 22%. The percent change in quantity supplied goes on top, 10%. The response, 10, is smaller than the increase in price, right? The thing that's changing on the bottom, 22. So 10 over 22, that's a little more than 0.4, if my mental math here is correct. So that's less than 1. 0.4 is less than 1. It's a fraction. The number on top is smaller than the number on bottom. So that's inelastic. Again, we could have the case of unit elastic, this kind of one-to-one thing. I'm going to skip it. And we could have elastic. A 22% increase in price leads to a big 67% increase in quantity supplied. So if the response is bigger than the price increase, we call that elastic supply. I give the example here of medication. Whoa, hang on. Weren't pills our example of inelastic demand? They are inelastic for demand. But what about on the supply? Is it easy to make more pills? If you need to make more pills, can we make more pills? Yeah, it's relatively easy to make another pill. Making another pill is actually not that hard. If you've already got the chemical formula down for most medications, you kind of just hit, make more on the pill making machine, right? Okay. I don't know how it works, but I know that supply is relatively elastic. It's easy to make a few more. If you don't like that example, use t-shirts. It is quite easy to make another t-shirt. Okay, yeah, you want more t-shirts? Well, we'll make another t-shirt. Okay. Some stuff it's easy to make, just simply produce more of, right? Okay, so we can go through here. If our calculated elasticity is equal to 0, meaning regardless what happens on the bottom of the fraction, the top is not changing. The top is a 0. The response is a 0. Then we say it is perfectly inelastic. And that's true for supply and demand, right? If it's less than 1, we say it's inelastic. The price change was bigger than the response. If it's equal to 1, it's unilastic. If it's greater than 1, it's elastic. The response was bigger than the price change. And finally, as we approach infinity, meaning little tiny price change, immense response, we get a very flat, elastic supply or demand curve. So that's kind of our other extreme here. Put it very simply here, If our calculated price elasticity for supply or demand, if it's greater than 1, elastic. If it's less than 1, inelastic. And hopefully now we have a pretty good understanding of why this is. All right, you guys, we'll call it there. I know this was a long one, but thank you for bearing with me and learning a little bit about elasticity. Thank you so much. Bye-bye. All jokes aside, it really is gorgeous out here on the terrace. Check this out.